Have you ever wondered how these large scale applications work? They have like millions of users, millions of connections coming in. So if you have like a single load balancer, then it'll eventually run out of memory and start throwing out of memory exceptions. But if you have like multiple load balancers, do you have this question? How are load balancers load balanced? So I'll answer this question where we have like multiple servers or multiple pools of servers in the downstream and have like a bunch of hierarchical load balancers and how the load is balanced across these load balancers. And our goal is to distribute the load across these servers in a fair manner. So when the user types in our domain, the authoritative name server resolves this DNS query into an IP. We can configure this DNS query to resolve to either the global load balancer that we have at the Uber level or directly the data center. Both will be using Anycast routing. If we choose the data center way, the DNS query resolves to the IP of the data center, and all the data centers across all the geolocations will be advertising the same IP. And the routing infrastructure, the network infrastructure that is there, that decides which data center the request is going to be routed. Majorly, it's decided on a hop basis. So if some of the network infrastructure components go down, the request might be routed to a further data center rather than the nearest data center based on the geolocation. Since changes to the infrastructure can affect how the requests are routed to the downstream servers in case of Anycast, one major issue with stateful downstream services is that the requests get routed to different servers in case there's a change in infrastructure. And the user state might not be present in the other server and might cause unpredictable issues there. The second approach is to advertise the IP of the global load balancer. This is much safer than directly advertising the IP of data center because malicious users might get to know our IP and do a denial of service attack on that particular data center and probably completely fail that data center altogether. So if we advertise the IP of the global load balancer, what happens is all our backend pool is behind that load balancer and it can distribute the load evenly even in case of a DOS attack. It can also do SSL termination. It can whitelist IPs and do rate limiting, throttling, implement a circuit breaker pattern to prevent cascading failures, probably use firewall in the global load balancer to prevent malicious actors from ruining our systems. The request comes at the global load balancer and it investigates the packet. This request is at the HTTP level because we have already resolved the DNS and we have sent the HTTP request to the global load balancer. So based on the origin, it forwards the request to the right data center based on the geolocation instead on the hop basis. This also ensures that session affinity in case of a stateful session is followed because global load balancer will have access to all the application level headers as well as the data that is there in the HTTP request to route it to the right data center. And at the data center level, we'll have multiple load balancers in case you have like hundreds of servers and you have like millions of connections. So we'll have a bunch of software load balancer instances. Again, at this level, we'll have to balance the load across load balancers or else because of those millions of connections, if the load goes to a single load balancer instance, we could be facing out of memory issues. To do that, we can't have a load balancer upstream because we'll again get into the single point of failure issue. To distribute the load across these load balancer instances, we'll use the network infrastructure instead of having a upstream load balancer again. Each software load balancer instance will advertise the same virtual IP, and there will be a bunch of ECMP routers upstream. ECMP stands for equal cost multipath routing, where if you have like multiple downstream instances, the router will use some intelligent algorithm to distribute the load even. In this case, we'll use a hash of source IP, source port, destination IP, destination port along with the protocol to route it to the actual instance. So if we have stateful services downstream, it will get routed to the same service based on the IP and port combinations. This is what a large-scale application serving millions of clients might follow. We have like hierarchical level of load balancing starting from the global load balancer then going to the data center with multiple software load balancer instances which balance load across the circuit. So if you like this video of dissection of how load balancers are load balanced, please give this video a thumbs up and probably subscribe to the channel uh, to get further notification about all these dissection videos that I'll be posting. Thank you.